evolutionary conservation is mapped onto the protein surface. Rather than being uniformly distributed, conserved residues cluster at the interaction interface. The interaction between RFC5 and PCNA2 contributes to opening the gap between PCNA2 and PCNA3. Here, we examine the conservation patterns of interface residues involved in this process. Conservation grades reveal a clear asymmetry at the interface. Interface residues on PCNA2 show consistently higher conservation than those on RFC5. In contrast, RFC5 interface residues display greater sequence variability, while retaining similar physicochemical properties across substitutions. Within the RFC interface, many hydrophobic residues show relatively low conservation scores. Despite this sequence variability, these residues play a critical role in mediating hydrophobic contacts with PCNA2. On the PCNA2 side, a complementary hydrophobic patch provides a tight interaction surface, and the residues surrounding this patch are highly conserved. Together, this pattern suggests that while RFC contributes adaptable hydrophobic contacts, PCNA2 maintains a conserved structural framework for stable interface formation. Notably, the conservation pattern of interface residues on PCNA2 remains largely unchanged between the closed and open states. In the open state, however, a greater number of interface residues participate in polar interactions, strengthening overall binding. Despite these additional contacts, the highly conserved PIP motif and its pocket remain the core interaction framework. This figure shows property-level conservation of interface residues derived from a multiple sequence alignment of 150 homologous proteins. Here, frequency indicates how often a given amino acid property appears at each interface position across species, reflecting evolutionary constraint at the level of physicochemical characteristics rather than exact residue identity. At the RFC5 interface, many hydrophobic residues display low sequence conservation, yet consistently retain hydrophobic character, indicating that interaction is maintained through conserved properties despite sequence variability. In contrast, PCNA2 interface residues show strong sequence-level conservation, forming a well-defined hydrophobic patch and a highly conserved PIP motif pocket. Notably, this conservation pattern on PCNA2 remains largely unchanged between the closed and open states. In the open state, additional polar residues participate in the interface, strengthening interactions without altering the conserved core. Together, these patterns suggest that PCNA2 opening is driven by conserved structural anchors supplemented by flexible, less conserved auxiliary interactions.